Hey Katie, so let's take a look at functions a little bit, and what we're dealing with in this section is all about composition of functions. Okay, so let's just kind of review what we know about functions. So when we're looking at this notation right here, we're just saying whatever we throw in for x, for every x you see over here, you're going to replace it with whatever gets thrown inside. Let's just practice that a little bit. If I throw in a 7 here, that means for every x, I would have to throw in a 7 in its matching place, and then of course simplify. Or if I were to throw in a negative 3 instead, well, then for everywhere there's an x, right up here, I would have to replace that x with a negative 3, and then you would simplify. Now, what we've seen in the past is that you don't have to throw in numbers. I mean, you can throw in anything you want. I could throw in u if I wanted to. And everywhere there was an x, that now becomes a u. If I wanted to throw in a y, let's say, well, the same thing. So you can throw in variables, you can throw in numbers, you can throw in a combination of both. I can throw in y plus 1, right? And that would just change all of these correspondingly. Now, I want to do something interesting here. I want to throw in 49x to the third. And we can do that. Works just the same as all the others, and then we would just simplify. 49x to the third. You probably already noticed, though, that this function right here is actually another function. This is my g of x. And this is what we mean when we're talking about composing functions with one another. Essentially, when we're saying, just looking at some of your problems here, like this would read, find g composed of f of x and f composed with g of x. That's all that we're doing, is we're taking one and we're throwing it inside of the other. So if I were to look back at this problem right here, if I wanted to find, I have to remember how this goes. I think it's f composed with g of x. I know when you're looking at it, like in this situation where the g comes first, the first one is the outside one. So you would actually take this guy, that's your outer function, and what you're going to run inside of the x there is your f of x. So this guy on the left side is always the one that's going to be on the outer side. So if I were to match them, if I wanted f of g of x, using the composition notation, this is the one we're looking at. You can actually just think of it as f of g of x, if that helps thinking about it that way. So that's what we're doing here. We're finding f composed with g of x. Now notice that g of x is that boy, right? That bad boy right there. So in order to help clear this up, I'm actually going to color code this a little bit. I think that's going to make it a lot easier to understand what's going on here. Let my f of x be, perhaps, maybe, be, let's go with a red color. Okay, so that means this guy has to match like that. Right here has to match. This might take me just a little bit to get this going. We're looking at, well, it would be that whole thing there, but let me come back to that here in just a second. We're looking at this part. Pretty much I'm just taking the old f of x function. Let me get rid of this. That'll make this a lot easier. I'm taking the f of x function and I'm just matching it with the red color here. So this will give me this whole section right here is now going to become that same red color. So we're dealing with this function right here. And what I'm going to do now is I'm going to take g of x and we're going to give it a different color. Let's give it, how about a dark green? That sounds good to me. So that means all of my g of x now is going to become this dark green color. Meaning everywhere there was an x, I'm going to replace that with a g of x. But not to confuse you, let's match the color on those. Let's make it that dark green color. And the same thing with this guy right here. So that's all that we're doing. When we're composing one function with another, we're just taking one and inserting it inside of the other, which just means that the 49x to the third is going to appear every time you see an x in this function. So think of it this way. The way I have it color-coded, I'm going to insert the green into the red. Every time there's a red x on the right side here, we're going to replace it with the whole green x term right here, and this is our result. So on the left-hand side, this is fine. On the right-hand side, let's go ahead and replace g of x, since it's the same thing as 49x to the third. That's what we're going to do right here, 49x to the third. And without simplifying, this is actually your result. Match the color on that. This is the process. All you'd have to do now is simplify. I don't want to simplify this. It's actually a fairly complicated problem. We're looking at 49 squared. That could be a nightmare. But instead, what we're going to do is take a look at some of your sample problems from WebAssign and just see if we can work through them and sort of make sense of them. This is especially useful when you get into calculus. You want to be able to recognize separate functions and how they're composed with each other if you ever get into calculus. I don't know if you want to pursue math that much, but if you did, that's the reason why they're teaching you this stuff, is because this is really useful. Okay, let's take a look at some problems. So when I'm looking at number 14, it says find g composed with f of x and f composed with g of x for the given functions f and g. Okay, there's my red function, there's my green function, if you want to think of it that way. Think g for green, although you could do it either way that you want. So the first one we're going to take a look at is inserting the red into the green. So I'm just going to copy those functions down. We have f of x is 2 over x plus 4. So f of x is... program didn't like me there. F of x is 2 over x plus 4. That's going to be our red function there. And when we're looking at our green function, it's going to be 2x minus 6. Replace this guy here with 2x minus 6. Alright, here's our red function, here's our green function. Notice that I've got the order reversed though, because we want to take the green one as the outer one, meaning I'm putting f into green, so to speak. So I actually want to reverse the order here. Let me just start clean with this whole thing. So what I'm going to do is just start with g of x, and that equals 2x minus 6. Make sure that's the right color there. So there's our green function. And what I want to do is replace the x with f of x, like so. And that means that this guy should be red. Let me go ahead and match that right here. Just like that. Getting picky here. There we go. Now they match. Okay, and then just to make sure we're consistent with everything, we're going to give this guy a red color. Okay? So this is what we're looking at right here. Now obviously you don't want to give your answer in terms of a function. What we want to do is replace f of x, that's the same thing as 2 over x plus 4. Well, I'm going to take this guy and just replace that with 2 over x plus 4, and then we're going to simplify. Just to make sure that we're all on the same page here, let's make that match the same color. Okay, so there's our composition. All we have to do now is just simplify it. I'm going to go ahead and leave that step there so you can look at it. But let's take a look at how this simplifies. And just so I'm not taking up too much time here, I'm going to go ahead and do this in black. So we're saying that g of f of x is the same thing when I multiply across the top. If it helps, think of it this way. 2 can be written as 2 over 1. In other words, the 2 here is the same as 2 over 1 here, and I'm going to multiply that by 2 over x plus 4. And when I multiply those, you can see that the 2 times the 2 gives me the 4 on top. And the 1 times anything, you know that has to be the other thing. So I can actually get rid of this part now. And then we're going to subtract 6. Let's go ahead and combine our fractions together. So it's going to be 6 over 1, just writing that in fraction form. And, well, you know, you may not have to do that. I think the computer will recognize it. In other words, you could type in this answer right here, and it should work. But let's go ahead and finish that thought out. So I'm going to write this as 6 over 1. To find a common denominator, this has to match with this, meaning I can multiply this guy by x plus 4 over itself, because that's all that's doing is multiplying by 1. Those reduce to 1, meaning 6 times the whole quantity x plus 4, well, that has to give you 6x plus 24 on top, and on bottom, same thing. 1 times anything is that same thing, so we can actually ignore this part now. And now I can bring the negative up. It's the same thing as multiplying by -1 right there. -1. And changing this to a positive. And so I can distribute the negative across both terms there. This will give me -6x minus 24 on top. And now I can combine my terms together. So we end up with this, and then for our final answer, g composed with f of x is the same thing as 4 plus -24, that is -20, and the -6x doesn't combine with anything, so I'll just copy it up on top there, and then we just copy our denominator down. And that's what we should be looking at for this specific problem here. This is what happens when you compose the f of x into g of x. I have to be careful how I say that. They were originally asking for g composed with f. And remember, you take the left one and that becomes the left one over here. So that's essentially how this process works. There's one last thing I do want to talk about here. I got to hustle. I've only got 4 minutes left on this recording. So I want to know what happens when you compose two functions and you end up getting just an x in the end. So if we look at this last problem here, number 19, we have f of x is 8 over 1 minus x, so this is going to turn into 8 over 1 minus x, and g of x is going to be x minus 8 over x. So this is going to be x minus 8, did that wrong, that's okay, x minus 8 all over x. So what happens when I compose one of these with another? Well, let's just take f of g of x. I assume that you're familiar enough with this process. Let's go ahead and change this to a black color. Okay, so when we're looking at this whole thing, I want to take f of x, which I can see is the quantity 8 over 1 minus x, but since we saw an x here, let's replace it with that guy right there. So this is going to turn into another fraction, x minus 8 all over x. That's the composition. Let's see if we can clean that up a little bit. Remember, when you have a complex fraction, you can always solve this by combining the bottom and then multiplying by the reciprocal. So I'm going to change 1 to be x over itself because that reduces to 1. Now I can combine them by distributing the negative up on top. It just changes both of my signs. X minus x is gone, and what I'm left with is just 8 over x, actually, is what that reduces to. So now what I can do is multiply by the reciprocal of the denominator, the bottom part of the fraction. So f composed with g of x has to equal 8, which I'm going to write as 8 over 1, and I'm just looking at the top part there, the topmost part. As I'm essentially saying, okay, that can be rewritten as 8 over 1. And now I'm going to multiply that by the reciprocal, which is x over 8. Notice that the 8's cancel, and this ends up being just an x. It's x over 1, which is x. Now the cool thing here is whenever this happens, when you compose one function with another, these two functions are actually inverses with one another. I'm running out of time on my video, so if you want, I can explain what that means later. But for now, just know that if you compose two functions with one another and you get just an x, order doesn't matter, at least I don't think it does. It probably wouldn't hurt to check both ways. But whenever you compose one with another and you get just an x, that's a sign that the original functions are inverses of each other.